Hello everyone and welcome back to another video, and today, after waiting so long, I'm finally doing something with the HD7950 XFX card that I got from my friend together with the GTX 480. And as you might hear, I'm finally recording a video in the morning and not in the late afternoon as I usually do, which means there's a lot of cars going through my street, so I'm sorry for that. Yeah. So this card is, as I've called it before, the immortal HD7950 because it has been through so much. I tried to kill it and failed. This card, it had so many things done to it and it's still working. And so I've decided I want to properly repair it, because at the time I got it, I basically had no idea how to fix this because I didn't have a hot air station, I didn't even have a proper soldering iron, nor did I have the knowledge on how to do things. Now I have, kinda, I hope. So yeah, this card is getting fixed and I've already done it, kinda. So if you remember seeing it the last time, you will see that there is a row of MOSFETs that wasn't there before, and that here is also a new MOSFET. Because when the card came in, it had this high-side MOSFET blown up. It actually failed open, so the card ran and everything was okay, but there was like a giant big crater in the high-side MOSFET. And you could actually see that this MOSFET didn't fail just because someone hot aired a new MOSFET on this card before and used a MOSFET that was significantly weaker than the other ones here. Like, the MOSFETs that this card come with are like literally the best MOSFETs I've ever seen in this standard package. I think it's called SO8. Like, these MOSFETs that these come with, even the ones that I've ordered, which are fairly high end, these are like nothing compared to the ones the card has. Like, both high sides and low sides are like extremely good MOSFETs. Extremely expensive also, like there are 1.5 euros per piece for the low sides, which is like almost 3 times as much as I've paid for my Vishay ones that I've put on here, and that's actually like, okay, I'm going into that later. So yeah, this card is coming with a seriously powerful VRM from the start, and I've not only repaired it with the new high side, I've also upgraded it with extra low sides. And all of these MOSFETs that I put on are the same old as SIR158 DPs. These are weaker than the MOSFETs this card comes with, but that's actually okay. Because, so the low sides are rated 100 amps for basically any temperature up to 70 degrees ambient temperature. Like 25 ambient, 70 Ks, 25 Ks, these do 100 amps. My Vishay ones do 60, and then 40-ish at 25C ambient, and then like 36, 34-ish at 70 degrees ambient temperature. So these are weaker. But that's actually okay, because if you think like it, if we actually need those 100 amps, and now have twice as many MOSFETs, that means that instead of 100 amps per phase, we now see 50 amps per phase on each MOSFET. And 50 amps is what these Vishay ones can do. So that's like actually okay. And then the high side, yeah, the one that I put on there is technically meant to be used as a low side, but it's a pretty good low side, which means the rise time is pretty nice. It's nowhere near the high sides on this, but like this has better rise time than most high side MOSFETs you see. Just not these, because these are again very high end. And then 1.8 milliohms RDS on, so the RDS on is really good on this. High sides normally have very high RDS on, but like they see basically no current, so that's not a problem. And yeah, so I hot aired on these new MOSFETs. This time I didn't blow, like this time all the caps survived, didn't blow any of them up. I again have a recording. It should be on screen right now again, because like, yeah, well, you can kind of see how I did that, and like now I'm gonna give you a close-up of the finished VRM, how it looks, what it looks like. So this is not looking that great compared to the other time I did this, which is, I think, mainly because I did a lot more MOSFETs this time, and also the space is kind of crammed between the inductors and the capacitors, whereas compared to the 460 that I did have a lot of free space. So this is why these look better, and also, yeah, like there's not as many phases as on this. So yeah, so this has a really powerful VRM now, and like, yeah, like this VRM should do very good. And one of the main reasons why I never bothered with the card is like I was missing several things. So the card came without a heatsink shroud, without fans, without thermal pads, and that broke in high side. So I was missing a cooling solution. I was missing cooling for the VRM, even though this is on the PCB where you can see like these exposed copper parts. This is the PCB that's meant to be able to run without a VRM heatsink, which it kinda is, but like stock maybe. Like stock, this was actually fine. I tested this without a heatsink, and stock it was fine, but like overclocked. Because the thing is, this card has a lot of interesting readouts in GPU-Z. You can see not just the VRM temperature, which is really nice, but also how much current is going in and going out of the VRM. And stock, there's like 50 amps at most going out of the VRM. So you could literally power this with like one phase of these 100 amp MOSFETs, and you wouldn't even max them out remotely. But when you overclock the card, if you give it more voltage, if you raise the clock, because this is a pre-boost card, like this is an OG 7950, which means this comes with an 800 megahertz core clock. And yeah, so this is running very low voltage. It's like running 0.95 volts and 800 megahertz. This card basically consumes no power whatsoever. But when you overclock it, you can go up to 1.3 volts, and this core, being a pretty nice core, can do 1250 megahertz. Then the VRM pushes 150 to like 170 amps. That's still not a lot, but there might be peaks way above that. So yeah. I actually forgot where I was going with this. Yeah. So when I overclocked the card, I absolutely needed a heatsink for this VRM. Also, I thought, I actually don't know, I never checked GPU-Z because at that time I didn't know it has these readouts. So one reason why I never bothered with the card is just I had no cooling for the VRM because I didn't have any thermal pads back then. You can see I do have thermal pads now, and I also have made a cooling solution because this was once part of the base plate. I cut it right here, and this now is the VRM heatsink. And yeah, so VRM heatsinking was one of the parts why I never bothered with this. The other part was just like one of the 6 phases was out, so these are extremely powerful phases, but like if I do some extreme overclocking on this, when I like water cool it, or just like want to go to really high voltages, I would like to have all 6 phases functioning. And again, I didn't have a hot air station back then, neither did I have any MOSFETs to replace them with, which now I do. So I did that. And yeah, and another thing is you can see the core looks kind of weird, because normally there's a metal piece around it. I don't know, like I think I've heard that there's 2 versions of the Tahiti core, which like is this core right here. Like I think I've once heard that there's a normal and there's a recessed version, and mine core is a recessed one. So that means this metal piece around the core is actually thicker than the core itself. So if you put a flat heatsink on this, which like pretty much all universal heatsinks are, because they have to fit any kind of core you use them with. This will not contact the core, it will just contact the metal piece on the outside. So I had to delid the card and remove that metal piece. And now I can use it with a custom heatsink. So that's another reason why I never bothered with it, but this was kind of easy, and I did that a while ago actually. Yeah, and now this is literally everything I had left for my thermal pads. Like I bought one cheap thermal pad to fix the VRM thermal pad on the Jetstream 970, and I had this left over, and this is exactly as much as I needed. So I'm now completely out of thermal pad again, but I don't really need any more thermal pads right now. So yeah, and then I took the base plate, like sawed it in half here, and then yeah, now the card has a VRM heatsink. One problem though is you can see like there's these two parts that kind of stick out, and that actually collides with both the Accelero and the Morpheus heatsink. So right now the biggest problem is actually thermals. Kinda, because there's another problem with this, which I don't quite know how I'm going to fix that. So I currently only have one heatsink that I can use with this, because like cutting the baseplate in half, I destroyed the stock heatsink, because like that had a vapor chamber that was literally glued on the baseplate, and I ripped that out, so the stock heatsink is now no longer functioning. So the only heatsink I have that fits is, I'm gonna get that, is this right here, which is, well, it came with the GTX 670, and like it kinda works, but if I get the card to run at some high voltages and high clocks, I do not expect this to do very well. And I was kind of thinking of putting a water block on this, but then there's the problem, this is an AMD card. AMD cards have different mounting hole spacing than NVIDIA, and my water block currently only has holes for NVIDIA. So I would have to disassemble my water loop and drill more holes into the block to fit AMD cards, which isn't that hard, it's just really, I don't want to do it. Like, I'm sure I'm gonna do it at some point, but it's just like a thing that I don't really like doing that. So yeah, I guess I'm gonna use this heatsink until it gets so bad that a truck drives next to my house. Yeah. I guess I'm just gonna use this heatsink until it gets so bad that like I literally can't use it anymore. Which might actually take a while, because right now the card can't run at max voltage. Kind of a similar issue to the RX 570, only that this is, I think, not a defect. Like, I actually don't know what it is yet, but I have a suspicion. So, the problem that the card had before is like it would run stock, but then like if I increase the voltage, the card would shut down, like completely shut down. You would have to power cycle the system to get it back, get it back up. And at the time I thought that has to be over temperature protection on the VRM, because it is completely uncooled, and I just shot a lot of voltage into the core. Plus one of the 6 phases was out at that time, so the VRM is probably just overheating. So yeah. Turns out it wasn't really. Like it certainly made it worse back then. Like the VRM was overheating, but the problem is still there, even with all 6 phases going and the phases even upgraded and cooling and all that. The card can run 1.2 volts, but not 1.3. It shuts down and it's not over temperature. Because in GPU-Z, like the card actually has 2 temperature sensors. I don't know where exactly they are, but they both show pretty similar temperatures, and the VRM currently maxes at like 65 degrees. or like 50, oh, 65, yeah, 65 degrees. So that's pretty cool for VRM. Like VRMs can do like, I think the ones that I bought are like 150 degrees, and the ones that are on here, like these are pretty high, and these are probably also around that. But most VRMs are like fine up to like 110 degrees. So this is far off high temperatures. The card still shuts down though. Like it runs longer than it did before, which again I suspect it was both overheating and having the problem that it has now. But it still can't run 1.3 volts because like it runs briefly for like a minute and then the card shuts down again. And again, like you have to power cycle the entire system to get the card back up working. So I haven't checked, but that behavior is kinda indicates that the VRM, like the card shuts down all the VRMs or like one of the major VRMs and never turns them back on until you completely power cycle the entire system. Which is like, that's a protection mechanism. Like it could have been over temperature protection. Now I know it's not, unless the over temperature protection system is broken and triggers way too early. But I don't think that would be the case. So right now I'm thinking it might be overcurrent protection because the temperatures of the VRM don't really change between 1.2 and 1.3 volts. But 1.2 volts, it hadn't happened yet. 1.3 volts, it's happening pretty fast. So what I'm thinking it might be, might actually be overcurrent protection, which I can solve right here. This is in CHA 8228G. There's documentation for this. People have done mods already to this. So if it's an OCP problem, I can solve that pretty easily. I just have to wire my mods so they fit under this baseplate here, because I need all of that. Like I can't just cut pieces off, even this, to fit the heatsink because, well, there's no connection here. Because like I need these for screw holes, and that one is like a bonus I never use. So yeah, I think it's overcurrent because like between 1.2 and 1.3 volts, the temperatures of the core don't really change, the temperatures of the VRM don't really change, but the current output of the VRM changes. It's like at 1.2 volts, it's like a steady 140 amps. And then on 1.3 volts, it's like 150 with like 170s in there. Like it's more current. And what I suspect might be happening is that like it has an overcurrent protection at like 200 amps. And then we just have to, like, it's just a question of time until the card like has a really nasty transient and like pulls 200 amps for like a couple milliseconds, and that's enough for the card to trip the overcurrent protection. Which the overcurrent protection is pretty useless right now because, well, again, I upgraded the VRM. Like, even with these 60 amp MOSFETs next to the 100 amp ones, like, these 60 amp ones, they can hold their 60 amps until they're pretty hot, and like with 65 degrees, they can most definitely hold their 60 amps. And, yeah, like, 60 amps... with like one of them is capable, the other one is capable of more, but because like our 60 amp is the bottleneck here, we can expect 120 amps out of one phase, and with 6 phases of these are, if my math is correct, 720 amps that this VRM could like theoretically deliver. It would overheat long before it does that, but like for a couple milliseconds, it would totally be able to do that. So having like a 200 amp overcurrent protection, which I suspect is what is happening, that's like completely unnecessary. We can just take the overcurrent protection off of it. Like I think the overcurrent protection is like what the stock card has, or like what all of the 7950s ship with for stock. Because I think like this VRM, the stock VRM on this with these MOSFETs is not the reference. Like that might be what you get on the reference card from AMD, but like I don't think this is what most 7950s run at. Because like especially at stock, you'd literally be fine with one of these phases, and you wouldn't even like max that phase. like again, I'm expecting the numbers from the POC to be correct here. Like 50 amps is like average at stock. And yeah, like that's literally half of what one of these phases is capable of with the stock configuration. So yeah, nah. The overcurrent, like if it's the overcurrent protection, I don't know it for a fact yet, but I'm strongly suspecting it's the overcurrent protection. So yeah, that might be what I do next with this. I might try to get the water cooling working on this. Like, this is an ongoing project. I think I'm going to do some more tests with at what voltages and what kind of current levels it's tripping, because that would be that would give me some data to pinpoint at like what's actually tripping it. Like, I'm suspecting it's overcurrent, so I'm going to keep an eye on the current, and if I see like some numbers that trip the problem and some that don't, I can be pretty sure it's overcurrent protection. Yeah, but that would be pretty much it. I can see the video is nearing 22 minutes. And yeah, am I doing benchmarks for this? Yeah, I think I'm doing benchmarks for this. So after this video I'm going to run this card. And I think a good card to go up against is my 670, because like the 7970 and 7950 were launched to compete with NVIDIA's 600 series, and the 7970 competed with the 680, and this competed with the 670. And yeah, so the 670 is basically the original rival of this card, though you're going to see that this is significantly outperforming it because AMD fine wine. But yeah, so I think I'm gonna run my benchmarks now. And yeah, I hope you all enjoyed the video. Thank you all for watching, and until we see each other next time. Goodbye.